Hello gentlemen. Purpose of this video is to look at this Excel spreadsheet that I created for you that will help you further understand the effects of the A, B, C, and D in the sine and cosine graphs that we discussed in the last video. And basically what I want to do is simply show it to you and then let you guys go and answer the questions in the worksheet that I posted online in our website. But I want to show you how it works basically and what you should be thinking about. Right here you have down in the bottom left-hand corner, you can choose either the sine or the cosine graph right here. And so I have it chosen to sine, so we can look at a sine curve. You're gonna see a couple different graphs here. Right now they're on top of each other, but you're gonna see a blue curve and a red curve. The blue curve here is going to be the parent function of the sine x function, and then the red one is what we're going to do to manipulate it. Okay, for example, if I want to change the amplitude, I can do that by simply using my slider bar here. Okay, and if I give it a moment here, it'll jump up, and you'll see that the amplitude now has changed. I hope. Let's see. No, to 2. Okay, there it goes. And so all I simply did was I left everything else the same in this equation, except now A is equal to 2. All right, and so that just doubled my amplitude. Didn't have any effect on my period whatsoever. Okay, I can see what happens if I make it negative. Okay, if I look at -1, as we know, if I look at the regular red function, the blue function, which is my parent function, if I put a negative in front of it, I'm going to flip about the x-axis, and that's what I've done here. And so this will allow you to change what the amplitude does. Let's put that back to 1. It does take a moment to adjust here. B affects the period. Okay, so I can change my period here. And now my period is twice what it was before. And so, as you can see, this is going to go, if I'm looking at 0 to 2 pi, which is right here, this is about 2 pi right there, you can see that the red function has gone through 2 cycles, whereas the blue one, the original sine function, has gone through 1 function. Okay? D is my vertical shift. This is an easy one to see. Okay, and this is my phase change here, these are in pi over 4s, and so this would be a phase shift of pi, which you saw before. This is a phase shift of is 2 pi, and I get right back to where I started, and that's what the period is of this function. So that should make sense to you. Should also note that a phase change of, let's just go to pi, actually pi over 2, whoops, there's a regular cosine, right there. Right there, if I have a phase change there of 3 pi over 2, 3 pi over 2, it looks like just like a cosine function right here. See I'm sorry, I'm looking at the wrong one. No, not the red one. The red one looks like a cosine function now. So I can make a sine function look like a cosine function by using a phase change. Okay? And so if I went backwards pi over 2, if I shifted my sine function, my blue function, back pi over 2, then it looks exactly like a cosine function. Okay? And we can do the same thing with our cosine function here. Same idea. I have cosine, I can change my amplitude, etc., etc. Okay? So I want you guys to look. There'll be a worksheet online. This is how you use it. This should help you understand, the worksheet should help you understand the effects of A, B, C, and D. Okay? Again, any questions, let me know, and I'll be happy to answer them. All right, fellas? Have a good day.